In the previous video, we have discussed that how to convert a decimal number to a binary number. In this video, we are going to convert one binary number system to a binary number system to a equivalent decimal number. Okay. In the previous one, what we did, we take the decimal number. If I had to convert, let's say 53 base 10 to the binary. So, what I was doing, I was dividing 53 with 2 and then I was going. So, the answer will be, so it is 53. So, 2, 6, remainder is 1, then 2, it will be 13, remainder is 0, then it will be 6, remainder is 1, then it will be 3, remainder is 0, then it will be 1 and the remainder is 1 here. So, the answer is 1, 1, 0, 1, 0, 1. Now, in the conversion from decimal to binary, we got 53 to this number. Now, if I want to convert it to back here, so how do we do that? So, I have to write 1, 1, 0, 1, 0, 1. So, first you count how many numbers are there. So, this is 1, 2, 3, 4, 5, 6 numbers are there. So, what I have to do? I have to multiply the place value with its effective value. So, here I will write, so 1 into, so how many? 1, 2, 3, 4, 5, 6. So, I have to write here 25, 2 to the power 5. Okay. So, you have to multiply with the base to the power of the place, plus 1 into 2 to the power 4. So, consequently will go like that. Then plus 0 into 2 to the power 3. So, this is 0. Then again 1. So, plus 1 into 2 to the power 2 plus again 0 is here. So, 0 into 2 to the power 1 plus 1 into 2 to the power 0. Now, if we will find the total summation, we will be getting 53. So, let us see that 2 to the power 5 is 32. So, 32 into 1 is 32 plus 2 to the power 4 is 16 plus 0 into something is 0 plus 2 to the power 2 is 4 into again it is 0, sorry, it is plus 0 and then plus 2 to the power 0 is 1. So, 1 into 1 is 1. So, if I add this all these numbers, I will get 53 here. 53 means now we have converted this binary number to the decimal number. So, why I did this example is, in the first place we have converted this decimal number to the binary in this way, and then the same binary number we converted back to the decimal and we are getting the same number here. Now, let us take some other example as well. So, if I take, let us say 1, 0, 1, let us take a small one. So, this base 2, what is the value of this number in the base 10? That means convert this binary number to a decimal number. So, how to do? So, first I will count how many numbers are there, 1, 2, 3. So, that means I will write 1 into 2 to the power 2. So, how many numbers are there? 1 less than that you have to multiply there again, plus 0 into 2 to the power 1. So, this one, then plus 1 into 2 to the power 0. So, what it will be? If first it is 4, 2 to the power 2 is 4, plus again it will be 0 because 0 is multiplied, plus 2 to the power 0 is 1 and 1 into 1 is 1. So, this is equals to 5. So, the answer here you have to write as 5. So, the binary equivalent of 101 is equals to 5. Okay. So, now what is the general formula for this? So, general formula is, if the binary number is B1, B2, B3 and B4. Let me write in the opposite way. Generally, if you see anywhere, it will be written in opposite way. Let us, there is a 4 digit binary number which is B4, B3, B2, it is a 5 digits, B1 and B0. So, like this the binary number is there. That means, this B0 value can be 1 or 0, this B1 value can be 1 or 0. I am just representing a binary number which has 5 digits, that any digit can be 0 and 1, and the question is how to convert that to base 10. A general formula I am saying. So, what is that? So, B4 into 2 to the power 4 you have to write, plus then the second is B3 into 2 to the power 3 you have to write, plus b2 into 2 to the power 2 you have to write, plus b1 into 2 to the power 1 plus b0 into 2 to the power 0. So, whatever the answer will come, that will be your value in the decimal number. Okay, like this, let us take one example here. So, we will take a small one. So, let me just write 1 0 1 1. So, what is the decimal equivalent of this number, we will find out. So, how to find out? So, see here how many digits are there, 1 2 3 4. So, I will write here. So, if I represent this as B0, B1, B2 and B3, right. How to convert that? So, B3 into 10 2 to the power 3. So, B3 is how much? 1. So, 1 into 2 to the power 3 plus B2 is what? 0. So, 0 into 2 to the power 2 plus again 1 into 2 to the power 1. So, this B1 place. Next, last one is B0, B0 is 1. So, 1 into 2 to the power 0. So, what will be the answer? Now, 2 to the power 2 to the power 3 is 8 plus this one will be 0 plus 2 to the power 1 into 1. So, that is 2 plus 2 to the power 0 is 1 into 1, that is value is your 1. So, that is equals to 8 plus 2 plus 1. So, that is equals to 11. Now, the answer for this one is 11 base 10, right. So, the binary decimal equivalent of 1011 is 11. Now, to simplify the things, you can remember from 0 to 9 what are the binary equivalent values. So, you can remember that. So, I will write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, if you can remember these 3, it will be easy. I will tell how to remember. So, see, to represent 0, so one example first you remember here. So, representing 101 is 5, that I know. Okay. Then I have done for 9, no. Okay. So, for 0 I will write 4 zeros, 0, 0, 0, 0. You can write 1 0 also, it is correct. You can write 0 0 also, it is correct. You can write 0 0 0 also, it is correct. So, why I am writing it is 4 zeros, I will tell you later. So, next is 1. How to represent that? 0, 0, 0, then last one will be 1. So, if you find the place values, it will be what? 0 plus 0 plus 0 plus 1 into 2 to the power 0, that is equals to 1. So, next 2 is 0, 0, 2, sorry, 1, 0. So, if I represent the place value, so it will be 0 plus 0 plus 1 into 2 to the power 1 plus 0. Wherever 0 is there, I am not writing the 2 power there. So, 2 to the power 1. So, that is equals to 2 here, right. So, what is the value of 3 now? 0, 0, 1, 1. Then I will tell you the trick how to remember this. So, it is 0 plus 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0, that is equals to 3 here. So, this is 2 and this is 1, the value is 3. Similarly, I can write for 4 also. So, that will be 0, 1, 0, 0. I can write for 5, that will be 0, 1, 0, 1. I can write for 6, that will be 0, 1, 1, 0. I can write for 7, so that will be 0, 1, 1, 1. I can write it for 8, that is 1, 0, 0, 0, and for 9 it will be 1, 0, 0, 1. So, how I directly write this without doing the conversion? So, see here the trick is 0 is 0, 0, 0, 0, 1 is the last bit or the LSB, least significant bit, you can make it 1. Okay. Then for 2, so the next digit you make it 1 and this one will be 0. For 3, then this one will be 1 and this will be your remain same 1, 1, 1. So, after this what will happen? So, this is completed, no change can happen here. So, the next change will happen in the next bit. So, for 4 we are making it 1, 0, 1. Then for 5, 1, 0, 1. Then for 6, 0, 1, 1, 0. So, I am doing, so from 1, 0, 0, 1 bit I changed, 0 to 1 it became 5. Next is 1, 0 was there, 0, 1 was there. So, this one was there. So, see after 0, 1, What is the next one? 1 0 is there. So after 0 1 I have made it 1 0. Then 1 0 is there. So after 1 0 what was there? 1 1 was there. So from 1 0 I change it to 1 1. So now the value of 7 is 1 1 1. Next is 8 is there. Then for 8 what will happen? After 1 1 what happens? It goes to the next digit will be 1. So for 1 1 1 has happened, then the next digit here it goes to 1, all other are 0. After that for 9 it is 1 0 0 1. So if I write for 10, how it will be? Simply I can write the 0. So 0 0, then 0 1, then 1 0. So see, this pattern is repeating. So this pattern is repeating. Again this pattern will repeat here. If I write it for 11, it will be 1 0 1 1. Okay, this pattern will repeat. After this, so for 12, how what I can write? 1 0 1 1 is completed. So 1 1 is completed, that means next bit will be changed. So 1 1 0 1 0 0, right? Then for 13 it will be 1 1 0 1. Then for 14 it will be 1 1 1 0, right? Then for 15 it will be 1 1 1 1. So like this you can write. So you can see again this pattern has repeated itself. So for 15 we can represent with 4 digits of values. So that is why to represent generally to representing any decimal number to binary number, we take help of combination of 4 bits. When you will read about more about the hexadecimal number, this thing will be used there in frequent manner. Okay. If I want to represent 16 now, then what will happen? The next bit will be 1, but here we have not taken. So that's why if we have to take, it will be 0, sorry, it will be 1 0 0 0 0. So if I convert that to decimal also, 0 1 2 3 4. So that is 2 to the power 4 into 1 plus 0 plus 0 plus 0 plus 0, all other are 0. So 2 to the power 4 is 16. So I will get 16 here as the answer. Okay, so this is how you can convert your binary to decimal number, and then you can remember at least up to the 9. Okay, if you remember up to the 9, then it will be easy for you to remember the things. Up to 9, so up to 9, how many variables required? 4 variables. How you can write? First write 0 0 0 0, this is 0, then 0 0 0 1, change the last bit only, it will be 1. Then again change the second bit 0 0 1 0, then 0 0 1 1. Okay, then the third bit will be changed 0 1 0 0, then 0 1 0 1, then 0 1 1 0. So see what I am changing. First I change this. So after this I shifted the change here and then made it 0. I changed this again. Then this is done. So no change can happen here. So next change has happened here. I made it 0. Then I change the 0 to 1. Okay. Then I change the next bit 1 to 0. So next one will be 0 triple 1. So this will be your 7. So this is how you can remember the binary to decimal conversions. So generally it is represented in 4 digits. Why? Because up to 9 if I have to represent, it has to be represented, 4 variables are required. 9 means 1 0 0 1. So 4 bit of representation is required for 9. That's why we choose 4 digit combination of binary number to represent a decimal number. In the next videos we will see how to convert from hexadecimal to binary, hexadecimal to octal, and all the possible conversions we will see.